In this video, I will show you how to do a seemingly unrelated regressions SUR in Stata. Before you watch this video, please make sure that you have watched my other two videos on SUR and SUR example. I have opened up here the Stata program, which you can download from my website together with the data, and I have already executed it, so we see the results on the left hand side. So let's go ahead and open the data and take a look at it. We have data on test scores here, and we have the two dependent variables. We will talk about systems of equations, and the first dependent variable would be the math score here, and the other dependent variable would be the reading score, this variable. So two dependent variables, and independent variables would be female, program, and also the social sciences score. So if we are defining the variables here, first variable y1 would be the math score, y2 would be the reading score, then we have x1, the independent variables in the first equations, female, program, and science, and x2, female and the social sciences score. And then I'd like to define a variable, one of the independent variables such as female, that occurs in both equations, because I'd like to test some restrictions. So this is x1 here, one of the variables in here. So when you modify this program for your problem, put here the dependent variable of the first equation, the dependent variable of the second equation, independent variables of the first equation, of the second equation, and this should be the same variable that you want to test for restrictions across equations. So using describe and summarize, we can take a look at the data. So we see that scores are 52 on average. We have 54% of the sample female, and so on. The first thing that we can do is run OLS regressions, and this is the way we know them. With y1 dependent variable and x1 independent variables, and y2 and x2 as dependent and independent variables. And these are the results that we see, and of course we can interpret, say, the coefficient on say on the science score, is that each 1 point more that you have in the science score, you will have 0.59 more points for the math score. So that's a very typical description of OLS results. And this is the OLS regression of the second equation. These are the results. So for the SUR, this is the command that we will use, SUR regression. And we would put the dependent and independent variables for the first equation, and then the dependent and independent variables for the second equation, comma correlation, showing that we have correlated errors. And these are the results that we get here. And now notice that these two equations are estimated jointly. And this coefficient that I interpreted before has changed a little bit from 0.59 to 0.53, and that's the impact of a science score on the math score. So you can also look at the correlation matrix of the residuals, and we have a correlation of 0.18, which is positive but not particularly strong. The next thing to look at is the Pagon test of independence, and we're talking about the correlation between the errors in the two equations. And we see the test statistic of 6.8, and the p-value is very small. Therefore, we have significant results here, which means that we do have correlation across equations. So the next thing that we can do is we can test cross-equation constraints, And here we're testing the coefficient on the variable x1 in the first equation and same variable x1 in the second equation. So this is our female variable that we have here. And you see in the math equation, female minus the reading equation for female, that's equal to 0. So this is the null hypothesis, this is the test statistic, and this is the p-value, and we see that it barely kind of missed significance. So therefore we cannot reject the hypothesis that they're equal to each other, which means that we can go ahead and impose this cross equation constraint. So the way to do that is we could put constraint 1, and here we could define that the coefficients on the x1 variable in both equations are equal to each other. And then we can do SUR regression, then again specify the equation for the first and for the second equation, and then we put comma constraints 1, and this would impose the constraints on these equations. So look at when it's estimated, you can see that the coefficients on female are now constrained to be equal to each other, and they turn out to be negative, but again they're not significant. And then we have the rest of the results are again a little bit different than what we had before. So this is how to impose constraints in case you have demand system or something like that and you want to impose those constraints. Thank you very much for watching, and come back again to watch more videos.